Welcome back, everyone. Today I'm going to be showing you how to dilate a function from the y-axis, right? In particular, we're going to dilate the function, sorry, y equal x squared from the y-axis by a factor of 2. So let's see what that looks like. Let's write it down what we know. So if that's the question, so the keywords the function that we're interested in, then we are dilating from the y-axis by a factor of 2. So those are the main key points in this problem, okay? Now, then if we're given this information, these three information, what we know is then the following, right? These are what we know. We know then, oops, let me change the color back to black. Then we have the dilation factor, which is k, is going to be equals to 2. And the transformation matrix is given for transformation matrix from the y-axis, dilating from the y-axis is given by k 0, 0, 1. And then we label the new point x dash. X dash is going to be equals to t times x, okay? And we know that x dash is going to be equals to, that is the same as x dash y dashes, little x and little y. The t would becomes k is going to be 2, 0, 0, 1. And this big X is the original value, xy, little x and little y. And if we expand this, we'll get, we're going to do x times 0, 2 times x, sorry. So going this way and down, we're going to get 2 times x plus 0 times y, and then we got 0 times x plus 1 times y, which comes from this 0 times x, 1 times y, right? That's for the bottom. 2 times x plus 0 times y, that's for the top row. And if we simplify that, we get the following. We get 2x and then y, okay? Therefore, we know that x dash, y dash, these are the new points, all right, equals to 2x and y. So this is the new, these are the new, the new point, right? So now, that's if we expand this out there, for from here we get x dash is equals to 2x and y dash is equals to y, and the y doesn't change as we have expected because we're moving it away from the x, just the x is changing. And what we want to do is we want to solve in terms of x and y. Solve I would say solve x and y for x dash and y dash. All right, so this is what I mean by that. So we're gonna do then, if we solve x, then x equals to x dash on 2 if we solve the first one, so that's for this one. And the original one is the same, y, which is just equals to y dash. So we're putting the old x and y in terms of the new x, all right? Then if we do that, and the next step is, so we're gonna substitute. So that's the first step. The second step is to substitute x and y back into the new the original function. So first we do the transformation matrix and we get the answer x dash and y dash. And then the second thing we did is we write the old x and the old y in terms of the new x's and the new y's. And then the third thing is to put, we're going to substitute these things back into the original and the original function. So the original function, okay, is given by y is equals to x squared. And if we substitute those values, y is equals to y dash, and x is equals to x dash on 2, and we're going to square that. And if we do that, we get x dash squared over 4. That's our final answer. So we could write the new function as y. We're just going to drop the dashes after we simplify them. So y is equals to x squared over 4. Okay, that's literally what it is. So what this means is if we have the function, so the function was y equals x squared originally, something like that. Y equals x squared, that's the original. And then the new function gives us y equal x squared 4, so it will dilate this one. This is y equal x squared over 4. So we're moving it away by a factor of 2. Remember, it was a factor of 2 from here. And the reason why we're getting a 4 there is because the x has been squared, which changed it into a 4, right? Instead of 2 here. We dilate by a factor of 2, but the function is being squared, so we get a 4 out of there. So we're moving that away from the y-axis. So we're moving by a factor of 4. Whatever point get moved a factor of 2 from it. Yep. And that's x, and that's y. Okay. And that's literally what we get. Let me show you these in Desmos. So over here is a notation. So we got the original function, which is labeled as with the black curve. I'm just going to undo that for now. This is, oopsie, the k should go there. So we can see that the original function is with the black colored curve. And then we saw that the new transform function changed into x squared divided by k squared. In this case, we got x squared divided by 2 squared, which is 4. And then if we put this into the function, y doesn't change. X changes into x over 2. Just let me show you what I mean by that. So x could change into x over 2, y, whereas y remained the same, right? So that's what it means when I write in terms of a functional notation here. Y is the same, but x transform into x over k or x over 2. So if k was 2, let's see what we get. I'm gonna graph that. So as I increase k, so it's gonna move away depending on as k grows, the graph will move away from the y-axis. And as soon as k equals to 1, they both will be the same, right? So let's see. 99. Yes, they are literally just sitting on top of each other. And as k moves away, as k get bigger than 1, it will move away from the original curve, and the value we're interested in for k is 2. So what do we get for that? Let's increase. Oh, that's over. It's hard to control this. Yep, there you go. This is the new function that we get when we dilate the function x squared from the y-axis by a factor of k, which is a factor of 2 in this case, right? So we can play around with this. So just to keep in mind, as k is, if k is bigger than 1, the original graph will be to the right of the original function, and it will move away. And as k is between 0 and 1, it will move towards the y-axis, right? It will be between the original function and the y-axis, just like when we do the dilation with the points. So, and as soon as k is equal 1, they will be the same. And then as k grows more, it will move away from the original function on both directions, the positive and the negative x directions. All right, this is a little graph to play around with. And I'll see you around, okay?